Stanford University.
Hey guys, so I'm Steve. I'm one of the TAs for CS 193P this quarter. Today we're going to be talking about using different tools to kind of debug your program, find errors before they happen, find errors when you have no idea where they're happening, that type of thing. I'm going to be talking about using the static analyzer and the debugger, and Sean's going to be talking about detecting leaks and also doing time profiling. So the first thing we're going to talk about is using the static analyzer. The static analyzer basically analyzes your code without running it to try and find potential problems in it before you actually execute the code. This can help you find bugs before they actually occur. So I've written kind of just a simple program right here. It's just called static analyzer, and it basically is just going to be a very simple program that has a custom view controller that's going to fill the entire screen. And the view controller, all it does is in load view, I just have a method called add name label, add class label, and then I slap a grade label on there and basically just throw some UI labels up on the screen, and it's going to run fine and everything's going to work. I'll just run it for you right here. You can see that's all it does. It works fine. There's no errors or anything. But what we're going to do is we're going to use the static analyzer to try and detect some of the possible errors that we have in our code. Okay, so if normally when you build the project, you can go build and then just build and run. What you can do is do build and analyze, or you can do Command-Shift-A as the keyboard shortcut to do that. So if I do build and analyze, what it does is it analyzes my code, and if I go up here to build results, okay. Okay, so if I look at my code right here, you'll see that it has some blue marks right here for possible errors that the static analyzer has detected. So let's just go through a few of these errors and see what the errors are. So for this first one right here, when I create the grade label, it says incorrect decrement of the reference count of an object that is not owned by the caller at this point. Okay. If I go down to the second one, it says potential leak of an object. And the last one is undefined or garbage value returned to caller. And oh, there's one more, another potential leak of an object. Okay, so we have these kind of potential errors that the static analyzer is saying we have in our program, although the program ran fine and nothing crashed when I ran it. Okay, so let's go through one by one and take a look at what these possible errors could be. Okay, so for this first one right here, where it says potential leak of an object allocated at line 70 and stored in grade label. Okay. So I have this method called give me my grade label, and it's just going to return a UI label, and then I'm going to put that UI label onto the screen. Okay, so the one important thing to remember is right here when we say grade label equals alloc init, that's going to return a retained copy of the UI label. Okay, so the retained count of this grade label is 1 right here. However, this method that we're going to return the label to is called give me my grade label. Okay. And if you guys remember the naming conventions that Apple has for their methods, well, this is totally fine. The caller of this method is going to own that object because it's going to have a retained count. However, this method called give me my grade label doesn't imply that. The only times that the caller of the method is going to own the object that's returned is when the method name contains copy or what's the second one? Copy or create. Or alloc, isn't alloc kind of reserved for Apple's special? But copy or create are the two times where the caller is going to own that, and you want to return a retained copy. New? Okay. So copy, create, or new is when you want to return a retained copy. So right here, a simple fix for this is just to do grade label, and we want to return an auto-released copy of that. Okay? Okay. And if we return the auto-released copy of that, then the caller of this method can retain it if they want to own the object, or if they're going to add it to the subview right away, adding it to the subview will retain it, and we'll be okay. So if we run the static analyzer again, okay, typo, auto release. Okay. So if we run it again, we notice we get rid of that static analyzer error. Yeah, you have a question? Yeah, so if you scroll down a little bit right here, you can see in the build results, it shows all of the possible errors that our static analyzer is detecting. He was asking if there's a way to see all of the potential errors in your project at once. And if you look at the build results right here, you can see all of the possible errors, and then you can scroll through them accordingly. Okay, so the other thing that we have, let's go look at this one right here. NS string name for student. We just want to get the name for the student. Okay, so we create in this NS string called S here. Okay, and then I just did some dummy booleans for what we're going to set the name of the student to. So if self.view.frames.size.height is greater than 100, we want the name to be Steve. Otherwise, we want the name to be Sean. Okay, and then at the end of it, we're going to return S. Okay, so the one problem with this is we have an if then else statement, if then else if statement. Okay, if neither of these things are true, we're going to return an instance of an NS string that hasn't been allocated. Okay, it's not even nil. We just have a variable called S. So you don't want to ever return an object that hasn't been created or hasn't been set equal to anything. Okay, so a simple way to get rid of this possible error is just to set S equal to nil when you first create S, and then that basically sets the pointer of S to nil, and then you're going to return a pointer that points to nil, and the receiver can then check to see, do I have a valid S? If S exists, it's not equal to nil, then they can act accordingly. Okay, so there's been some instances where you guys have had to create a global variable of some sort, or a variable that needs to persist throughout the lifetime of a function throughout if and else statements, and you always want to set the object equal to nil before you start executing any code. Okay, so analyze it again, and we get rid of that possible error. Okay. This method right here, there were, in the last few assignments when you guys have been doing the graphing calculator, I've seen a number of errors that have to do with memory management. And one of the really good things about the static analyzer is it goes through and it can detect a lot of the memory management errors before they happen. But you do have to remember that the static analyzer is not necessarily always 100% right. Like that first error we fixed, if you really did want to return a retained copy of grade label, that's okay. You can do it that way if you know how your program works, but it doesn't follow the conventional naming standards that have been established. So if someone else came in and was reading your code, they could expect an auto-released copy here when they're really getting a retained copy. So it's good to follow the naming conventions and use the static analyzer, but it's not always necessarily true, but it's good to detect some of the errors before they happen. So if we look at this one right here, potential leak of an object, we just create a UI label, a local variable, and then we slap it onto our subview. Okay. We always have to remember when you add a subview to a view, it will retain that view. So what we have to do, some people had errors in their assignments 3 and 4 with that, is just after we add the class label to the screen, we need to release it. Okay. And that's a pretty simple catch, but if you guys if you're coding really fast and you make the mistake of forgetting to release a view after you add it, and it's just a local variable that you created right there, the static analyzer can help catch that for you. Okay. And we do the same thing with our name label here. Okay. Name label, release. Okay. And we get rid of that error. Okay. And so the other thing is right here, we have an auto-released copy of our grade label now because we've correctly changed our code. So UI label, grade label is give me my grade label. That returns an auto-released copy of the grade label, and then we release it. We don't necessarily want to do that anymore because we just have the auto-release copy. We're adding it onto our subview, or adding it to our view. Our view will now own that subview, and we don't have to worry about releasing it anymore. Okay. Before, if we did return a retained copy, then we would have wanted to release it, but we don't have to worry about that anymore. So if we do that and then run our program, you'll see we get all green check marks because the static analyzer didn't find any potential problems. So our code looks good to go. So the static analyzer is just kind of a good tool to tell you that these are potential problems with your program. They're not necessarily going to crash it or break anything, but it's kind of just a good thing to have in your back pocket for when you're writing lots of code really quickly. It finds kind of potential errors that you could have made along the way, and you just do that using build and then doing build and analyze. Okay. So this second kind of trick tool I'm going to show you guys is the debugger, and this is a much more in detail thing for tracking down more gnarly bugs that are a little bit harder to find or could be more mysterious bugs. So I have a second project that I created, okay, right here. You guys just learned about table views the other day. I'll just demo this project for you guys real quick, what it does. It's a pretty straightforward project. It just has a basic table view on the screen, okay, with just a bunch of names. Okay, so it's just displaying a bunch of names of people on the screen. And then if I click on a particular name, it takes me to a detailed view of that person's name. Okay, so I can look at a detailed view of that person's name, and then I also have these buttons up here, this segmented control right here, that I can use to scroll between different people in the table. So I go from Freddie Sanchez to Aubrey Huff, Buster Posey, and then I can go back up and I can just check out my table view. Okay, so it's just a very simple program that has a very basic table view, and then it allows you to scroll through it. However, I'm having some weird problems with the program, and I'm getting some unexpected crashes. There's no, it's not like I'm accessing an array out of bounds, or I'm accessing something that hasn't been allocated yet. It's just weird crashing. So if I go look at Andres Torres and I scroll around, it just crashes. Okay, and if you look at the console right here, it doesn't print anything out. I have no reason, I have no idea why it's crashing, no idea to why it's crashing, how it's crashing, and I don't even know what line could be causing the crash. Okay, so this is in office hours a lot. We get people who come in and they have this exact problem. It's my code's crashing and I have no idea why. Okay, so if we just kind of, I just want to walk you guys through the code so you kind of have an idea of how the code is working. I know you guys just learned table views recently, but basically in our table view controller, we're just going to have a thing called a players array. And that players array is just going to contain a bunch of player objects. The player objects is a very simple class that just has a first name and a last name. Okay? And so when we create our table view controller, okay, we init it and we create 9 player objects. Okay? These are all created with our new player method right here, which returns a retained copy of a player object. It just sets the first name and last name properties of the object and then returns it. So we create 9 of those objects. We insert them all into our players array. So our players array now owns those objects, so we can release them. We don't need to worry about them anymore. They're in our players array. And then when our table view asks for the cell that it needs to display, we basically create the cell if we need to, and then we just set its label equal to the corresponding player first name and last name using the index path.row, which I know you guys all just saw all this yesterday on how to create table views, so it's moving pretty fast, but you get the basic understanding of we just have a bunch of player objects and we're just displaying each of them in a table view, okay? In each cell in the table view. Then when we click on an individual object, okay, we'll select row at index path. Okay, what we do is we have a thing called a player detail view controller, which just contains one UI label. Player detail view controller just has a label that displays the player's name, and it also has passed in the player that it needs to display. And that way it can draw that player's first and last name on the screen. So in order for the table view controller to interact with the detail view, okay, so you notice I'm in my player view controller, or my table view controller, and then I go to the detail view. Okay, they need to interact with each other, because if I click the down button, this detail view controller right here has to know the table view can give me another player to display. Because you notice when I get down to the bottom of my table view, this button becomes disabled. Okay, so they need to be able to talk to each other to know exactly, do you have more players to tell me, to give me, or do you have less players to give me? Should I disable this button or enable the button? So the way that we do that is with a player detail view controller delegate. And that's just really simple 4 methods. Can show next player, can show previous player, and then give me the previous player or give me the next player. And it's just a very simple delegate call where I say, if you can give me a next player, then give me the next player. If you can't give me the next player, then I'm going to disable this button and I won't show it accordingly. So it's a really simple, simple program that just kind of just allows you to go through a table view when you're looking at a different screen. Okay? So going back to this crashing problem, I have no idea why this crashing problem is occurring. Okay, so let's just go through it one more time, and I'll show you what's happening. So if I click on Andres Torres, okay, I can go down, look at Freddie Sanchez, fine. Aubrey Huff, fine. Go down, back to Freddie, go back to Andres. Okay, I can go through and I can look at everything fine, and it seems to be working, and then it just randomly crashes. Okay, so I have no idea why it's doing that, but the debugger's not, or the console's not really telling me anything. I'm not really getting any hints from it. Okay, but it has to do when I'm changing between players. Okay, so The first, I think a good point to start usually is let's go set a breakpoint at that area, okay? And let's check it out. Why is it crashing when I do that? Okay, so I have this method called segment action, which is called every time I start scrolling through my players, okay? And basically, we won't go into the details of this code, but I create a new player object, set it equal to nil, like we talked about earlier, and then I go through and I get the new player if my delegate can give it to me, okay? If I do have a new player, I say, okay, self.currentPlayer equals new player, okay? And so my first thought when the console is not showing me any information is I'm probably crashing because I'm using memory I shouldn't be using, okay? So if I go look at my .h file, I have this current player instance variable, which is a property. I retain it. So if I'm using the right getters and setters right here, I should be retaining that object. I own it. It's all good. And then when I have a new one, I release the old one, get the new one, and set it equal and retain it. So it looks like my memory management is fine. But if I set a breakpoint right here, okay, and then I run it, okay, what the debugger is going to do is when I do reach the breakpoint, it's going to take me back to the screen, and these buttons will be enabled: restart, continue, step over, step into, and step out. And I've seen some of you guys using the debugger in office hours, and a lot of you guys have, I think, a good grasp of the way it works. Basically, if you see right here, I'm at the breakpoint, so the code is all stopped executing at this point. What I can do is I can choose to step over this line, which means go to the next, execute the line you're on, and then go to the next line, and don't execute anything else. So if I step over right here, it executes it, and now I'm at this line right here, and you can see the new line is highlighted, okay? And a very common thing to do is to use the PO function in the debugger, which stands for print out, and it's basically like an NS log at this current point. So if I look at where I'm at in my class right now, I have this variable called current player, I have this variable called new player. So if I want to print some stuff out at the debugger, I go over to the console right here and I type in PO, and then I can type in whatever I want to print out. And you can print out objects, you can print out pretty much everything here. So if I print out current player, okay, I have a player object, and it gives me the address in memory where that object exists. It's a valid object, it's there. It hasn't been deallocated, it's not muck memory yet, okay? So if I print out, let's say I want to print out the new player, okay? It's a player object also, so it looks like everything is okay. There's nothing wrong. Those objects are valid objects in memory, so I'm not doing anything wrong, okay? So if I go back to, if I go back to the debugger and I want to continue running, because it looks like everything's okay. So I hit continue, okay? And that basically means you're just going to continue running the program until you hit another breakpoint. Okay, so I continue. We haven't hit a breakpoint yet, so if I go back to Andres Torres now, so I want to go back up, okay, I hit the breakpoint again, okay? So let's try printing out the current player again, okay? Looks like it's still there. Print out the new player. Whoa, it says new player does not appear to point to a valid object, okay? So for some reason, the first time when we went through and executed the code, new player and current player were both good objects in memory. However, the second time I went to look at the player object that was Andres Torres, it says it doesn't point to a valid object anymore. Okay? So yeah.
The red means out there.
Where?
Like in the top right in like the visual debugger.
In the visual debugger.
So top right.
So that means that the object that visual object name is pointing to, so the new player object was recently changed.
Mm-hmm.
Okay.
It's kind of like a time profile of when that memory address, that value has been changed.
Okay, so the only way to know that that's not valid is to type it in GDB.
Yep. Unless you really want to traverse the hierarchy,
Okay.
but it gets really messy.
Okay.
Yeah, so basically you were asking what this red means, and it means that the value of this variable has changed recently. Okay. This the red text for this for the new player object right here. And you can go through and you can and look through the properties of the object. Okay, but so going back to our memory management problem, we have no idea why this object doesn't seem to exist anymore. It's kind of been pulled out from underneath us, which doesn't make any sense because we're using the built-in getters and setters, retaining the object, so we should own it. And then when we change the value of the object to a new current player, we release the object. So we're retaining, we're releasing once. So it seems a little weird why we would be crashing. Okay, so I want to take one more look at it. We started out with Andres Torres when we looked at it, and it crashed when we went back to Andres Torres. Okay, so if we look at Aubrey Huff, let's say, we scroll down. Okay, we continue. Okay, we go back to if I go back to Aubrey Huff, okay, continue, okay, I get exe bad access. Okay, so that basically means we're accessing memory that we shouldn't be. Exe bad access means that you're trying to access a memory that's been pulled out from underneath you, it's been deallocated and freed, and that memory is no longer valid. Okay, so right away I know I've used the debugger to say, okay, I'm releasing something that I shouldn't be, which seems kind of weird because I'm using the built-in getters and setters for my current player. Current player is a retained property. I retain it right here. So how could that memory be pulled out from underneath me? The only time when I create the objects is right up here. I have a retained copy of the player object. I add it to my array, which retains it. So the retained count's now at 2, and then I release the object, so the retained count's still at 1. So it seems like I'm doing everything right with my memory. Okay, so the one other thing that I would look at is I would check and I would say, okay, how about if I try and go back, if I look at, I kind of want to narrow it down, which view controller is doing the releasing that it shouldn't be? Is it the table view controller or is it the detail view controller? Because it looks like my detail view controller is fine. So if I go look at Freddy Sanchez and I come back, take out these breakpoints. Okay. So if I'm looking at Freddy Sanchez, I'll start over without breakpoints. Okay. So if I'm looking at Freddy Sanchez, I scroll down, I look at some other stuff, and then I come back. Okay, everything seems to work fine. Okay, if I look at Andres Torres, okay, for some reason I get an exe bad access. So this bug seems to be a little bit weird, and it seems to be kind of strange in the fact that it's inconsistent in terms of when it crashes. Okay, so running it a few more times, one thing that you'll always notice is if I look at Andres Torres, okay, and then I go back to Andres Torres a few times, okay, everything seems to be fine, okay? If I scroll him off the screen, though, and he disappears, then I get the crash. Okay, so it has to do with something with the first object you look at is getting messed up, okay? So if I go and I look at my program, okay, it has to do with the very first time I look at a detailed view of a player. So it probably has to do with something when I'm creating my player detail view controller, okay? So when do I create my player detail view controller? I create it when they actually, in my table view, when they click on a particular player. So I create it right here. We'll select row at index path, player detail view controller, alloc init with player, and I pass in the player, okay? So let's go take a look at my init with player method, okay? So my init with player method, it takes in a player. If super init doesn't work, I set my current player equal to my player. Okay, right there, I think I found my problem. Okay, does anybody see what the problem is? What's that?
Is it that you don't retain the player and you pass in?
But my current player is a retained property. Yeah, so it's a retained property, so I should be retaining it right there. But I don't do self dot, exactly. Okay, so the problem with my code is if I just do current player equals a player, I'm just saying that the current player object, its pointer is going to point to the same place in memory that a player's object points to. Okay, it doesn't do anything though. It doesn't do any retaining or anything. It just is pointer arithmetic. It just sets the pointer equal to wherever a player is. However, if I do self.currentPlayer equals a player, what it does is whatever the current player object is, it releases it. Then it takes the pointer, points it to whatever a player is, and then retains that object too. So remember, you have to use the self dot property in order to get the built-in functionality of Apple's retain and release functionality. If you're just using the instance variable itself, it's not going to work. You have to use the self dot And that's going to lead to a lot, forgetting to use the dot property could lead to a lot of weird bugs when you're using table views, because you're going to be reusing cells, you're going to be reusing labels and stuff when you reuse cells. So it's important to use the dot property when you're accessing the properties of different objects, because you want to get the retain release functionality that you expect to get. So does that kind of make sense, how we kind of use the debugger to go through? And the last thing I'm going to show you guys, which is actually a really cool thing, and it would make solving this a whole lot easier, is something called NSZombie. NSZombie is just a kind of a tool that is built into Xcode that basically tells you when you're using memory that you shouldn't be. So the way that you set up NSZombie is, just to prove that it works too, I'll just run the program right now. Okay, and we can go through. Everything works fine. And our table view works as expected. Okay? So the way that you set up NSZombie is you go to your executables right here on the left-hand side, and you select your project. Okay? Go to the info for that project, and the arguments that you want to pass in. Okay, you want to pass in an argument saying that I want to use NSZombie. So variables to be set in the environment, you create a new one called NSZombie enabled, and you set its value equal to yes. And basically what this does is it just tells your program, I want to use NSZombie. I want you to use this tool. And basically what NSZombie does is when you release an object all the way down to having a release count of 0, rather than actually freeing that memory, it takes that object and it says you're an object of type NSZombie. Okay? So it doesn't actually completely free the memory, it just says you're an NSZombie object. Then if you ever try to access that object again, it's going to know you're trying to access an NSZombie, which it knows is invalid, and it'll throw an exception. So if I make this error right here and I take it out, okay, and then I run my program with NSZombie enabled, okay, if I go through and I'm looking at some stuff, boom, it crashes as usual. However, now with NSZombie enabled, we get this print statement, which says section table, message sent to deallocated instance here. So I know that it's a memory management issue. And then it also tells me the exact method right up here where I tried to access that object. I was trying to access the current player object that I shouldn't be and set current player. Okay, so we get a little bit more of a detailed explanation for why this error is occurring. So if you're ever having weird memory management problems and your program's just crashing without really any explanation or rhyme or reason, and you have no idea where the line is occurring or anything like that, you can use NSZombie and it'll give you kind of a more detailed message, and then you can use the debugger with a much more specific area in your code to examine why the crash is occurring. So, any questions on NSZombie? Yeah, so from your project, you just go to the executables, okay? Highlight your project, click on the info button, okay? And what you want to do is you just want to create a new argument down below, variables to set in the environment, NSZombie enabled, and set it equal to yes. And then you can just check it if you don't want to have NSZombie enabled the next time you run the program. Any other questions? I don't think it'll really matter, no. If it's enabled, that means you fixed all the problems. So, yeah.
So what else can NSZombie do for you besides this example?
The only times I've used it is just to detect when you're accessing memory that you shouldn't be. The concept of an NSZombie is just basically you take deallocated memory and you make it a special type, and you should never access that memory again. And if you do, an error's thrown. I haven't used it for any other instances besides that, and I'm not sure if it has more uses. So. Any other questions? All right, cool. So Sean's going to talk about time profiling and also about detecting memory leaks. So.
Okay, so I'm Sean. I'm one of the other TAs if you haven't seen me yet, been in my office hours. So what I'm going to talk about today is kind of some tools that Apple provides to help you kind of polish up your project before you want to send it into production, and also to help you kind of figure out, all right, I have this really slow method. What's going on under the hood? Where am I spending a lot of time? How can I optimize this What can I do to make this better? So the first thing I'm going to talk about is something called leaks. And Apple provides you with Xcode when you download the iOS and install everything, this thing called instruments. If you don't have it, you can just, if everyone doesn't know, command space, and you can type in instruments, and it'll bring it up for you. So you're going to want to look at the iOS simulator. Unless you have an iPhone 4, you can run the time profiler on your iPhone 4. I'm pretty sure you can run leaks on iPhone 3G and lower. Okay, but the profiler only works on iPhone 4. So what we're going to do is, if you look at all these different tools, you can explore all the different ones in your free time, but this automation tool is really good if you've ever worked on like front-end automation. You can write scripts that run programs to verify the functionality of your application, so you can do regression testing, stuff like that. There's other things like there's a zombies application, but we're going to be mainly focusing on allocations, leaks, and the time profiler. So just to give you a brief overview of it, it's just an instrument. You open it up, you can choose a target, you can attach it to different processes. And I'll show you when I actually run it, but it'll show you what memory you're allocating and what memory that you're allocating that you are also leaking. So we'll dive down deeper into it when I do it. So I just created this simple application. It's called Leaky, and basically you guys are very familiar with this code. Create a navigation controller, push a view controller where I have a custom init function, push that view controller onto the nav controller, and then add the nav controller to my window. And so this Leaky view controller it has a name, a profile image, and a contents tracker. So I'll just run it real quick so that it'll make a lot more sense when I explain so ignore these buttons for right now. These are just kind of demonstration later. But all this is it has an image in the background. It has these 3 options, and it basically just allows you to create this huge navigation stack over and over and over. And then you can drop all the way back down. So pretty simple. So the Leaky view controller will take, it takes a display name and an image name. The display name will be the name that it puts on the navigation bar, and the image name will be the name it uses to look up what image to display as the background. This isn't exactly scalable, but it's just kind of simple for our purposes. So basically it comes in, I create a mutable string, I alloc init it with the string passed in, and I set it to my name. Contents tracker is just an array where I can track which buttons people pressed. So I can later, like, if I want to do some kind of metrics tracking on my application, or I just wanted to display that to the user somehow. And so in load view, I just create all these buttons, I add them on, create lots of objects, just is a really stupid for loop that goes 1 to 1,000, creates a dictionary, sets an object, and that's it. So you should be able to see right off the bat that this is leaking 1,000 dictionaries at a time. You press that button, and then this alert button is just giving you an alert view that shows you the contents of that contents tracker, just so you were convinced that I was telling the truth, that we were actually tracking those contents and it had value. So, so what I'm going to do is, there's 2 ways to run it. You can go here. I can launch my process already. Whoa, my simulator. And then you can go here and you can choose a target. You can attach it to the process manually. And then you hit record, and it'll start recording. You can go back to your application. And you'll be able to see that when I push this view controller on the stack, right here you can see I allocated a bunch of memory for that view controller. And every time I push it, you can kind of see that I'm going to start allocating all this memory. However, when I go back, and it's on a 10-second check cycle, you see that I leaked some memory. So every time I pop these windows, these view controllers off the navigation stack, it's going to deallocate that view controller because I passed it to my navigation controller and I released it. So the navigation controller owned it. When it pops it, it releases it, that deallocates it. So you can see that I'm leaking some memory there. So kind of the way you want to get value out of this tool, the way you kind of interpret everything, is you go down here, you choose your leaks. The easiest way that I find is just to look at the call tree, and you can also show individual leaks. You can set the time between detection. Currently it's every 10 seconds it'll check for leaks. You can set it to 1, whatever you want. So then basically you look at this call tree and it'll show you what happened in the call loop. So this is all just kind of application code that you don't see under the hood. But this event callback is the button was pressed. It sends the event, touch event. Keep going, keep going. And then it says image button pressed. So finally we push this navigation controller, or push this view controller onto our navigation stack. And that creates this view controller that creates this mutable string and that's where our kind of loop ends. So we know that we have a mutable copy of this mutable string that we're not releasing, and it's happening when we're going back, we're popping that navigation controller. So another way to look at it, you can look at the actual leaked blocks, and it'll tell you, okay, I have this leaked string, it was leaked here. I have this array that was leaked. I have another string, more strings, arrays, etc. So the way to, so that kind of tells me, all right, I'm running this application. When I'm popping this view controller, I'm leaking all this memory. So it's a pretty simple error, but I just forgot to deallocate it in my, so I say self.name equals nil, and self.contents tracker equals nil. So those errors will go away. Or so we think. So another way to run it is to go to run. After it's built, run with performance tool leaks. That'll run it again. So this starts it for you. This is the allocation of most of the application memory. So you can see again, okay, I push it on. Hopefully when I go back, it shouldn't be leaking it anymore. But once it comes through, I'm actually still linking the string in this array. So I have to go back into, it's the same error as before. I'm using the accessor and I'm retaining it twice when I shouldn't be. Does everyone understand why that was happening? I was using my property retain accessor and setting the object that I was allocating, which already had a retain count of 1. I was using my property accessor that retains it again. So I had a retain count of 2 on every string and array that I was creating. So when I deallocated it, this is correct. I'm properly releasing this object that I had retained, but this object had a retain count of 2. So it never actually gets deallocated because it still has a retain count of 1. Nothing points to it anymore. So hopefully if we run this again, instruments is a little finicky sometimes. Okay. So now if I push this on, I come back, you can manually come in, check for leaks. So, oh man, I'm still releasing. Oh, it's because I didn't build it after I made the changes. So you have to, once again, you have to build it when you run. Doing run with performance tool takes the executable you already have built. All right, so hopefully those strings and those arrays, I'm going to come in and I'm going to manually say check for leaks, and I have nothing. So that helped me kind of clean up my view controller code. And this is really useful when you have huge applications where you don't really have time to go through and check everyone manually, but you can run these use cases and figure out, all right, I'm leaking memory here, I'm leaking memory here. It's really useful. It also catches stuff that the static analyzer doesn't necessarily catch. Since the static analyzer isn't sound and complete, this will catch most of your kind of standard bugs. Two things to be careful of with leaks is strings. The compiler does really weird optimizations behind the scenes that aren't necessarily transparent to you when you're coding. So if I was to make this an NS string and I was to alloc and init it, and I never released it, it wouldn't show up in leaks because the compiler is doing some weird memory optimization behind the scenes where that memory isn't actually being leaked, but my program for correctness still needs to do the right thing and release it down here. So it's just a disclaimer that it won't find all of your errors. The other thing is, I have another error here where if I ran the static analyzer, it would say, that's actually in the wrong line, but this line, I'm creating this button, this is an auto-released object, and I'm retaining it, but I'm never releasing it. So the leaks didn't find that either, most likely because of compiler optimizations on the UI. Another thing you can see, just so you can, I'm going to press this leaks button that I created. So all this does is this does the huge, so now I'm going to go in and I'm going to set my time to 1 second, and I'm going to tell it to give me all of my individual leaks. So when I run this for loop, you'll see that I got this huge block of this is kind of annoying, but you just have to kind of traverse this hierarchy. You can see there's the dictionary that was being created. Cool. Any questions on leaks? How to use it? No? All right, so the last thing I'm going to show you is a thing called the time profiler, and it basically just samples your program to figure out where your program is spending the most time. So this is an extremely simple application that just has a big button that when I press it, does a whole bunch of stuff, and then it prints me my results. But as you can see, it takes a really long time. And I want to figure out what is actually happening inside this loop that's causing all these problems. So basically, it's just a button that has this action attached to it. This action comes in and it says I'm starting, creates a mutable array. It loops over 2,000 times, and it adds an object to the array that uses this generate object based on int, which just takes the loop integer and converts it to an object based on random criteria. It's all just modding. And then it prints the contents and it tells me I'm done. So this comes in, this generate object, and if it's a multiple of 100, I'm going to do a string that says number. If it's a multiple of 50, I'm going to do a dictionary. If it's a multiple of 5, I'm going to create just an NS number. And if it's odd past that, I'm going to create a date. And I don't know if you guys have used NSDate yet, but you just create a date formatter, and then it's going to take this string, parse it correctly into the date format that I'm expecting, and it's going to set the object to that date. And this is all fine because I'm using ID, as we've learned about. And then finally, if it's even and it's past all the others, it just creates an image. So this is pretty simple. So what I do is, as you can tell, it's kind of a mundane application. It doesn't really do anything. But if you imagine you have a parser, that you're getting this big JSON response from a server, and you're converting those into objects that you're then displaying to your user or storing in your database, you want to know where in your parser it's being like the most inefficient, where you can kind of optimize the different objects it is converting from strings back into objects. So basically, it's very similar. I can run it with the performance tool time profiler, and then I'll start my application. And it's really useful when you have multi-threaded programs to separate it by thread. This is a single-threaded program. We'll be learning about multi-threading soon. And then to also do not invert the call tree. You want a regular call tree. So I get this huge computation. You can see that all this time was spent right here, my application. And then you can go traverse down, have all these run loops done by the application. And if you look on the left here, you can see it gives you an actual physical time, and then a percentage of time that your application spent in that method. So I can see that this run loop took up 100% of my time. That makes sense. So I go back to this call event, which took up 99.7% of my CPU time. So that kind of makes sense. You're pushing this button, it's doing all this crazy stuff. So you just kind of always look down into the, just look at the left, all this lower stuff that has 0.1%, it's usually meaningless. So the touches end. Finally, I get down to generate and display objects. And this is what I'm expecting to cause all the problems, because this is what I'm calling when my button gets pressed. So I can see it spent 816 milliseconds, 99.2% of my time. And if I can explore that deeper, and I can see, all right, 62.5% of that time is spent printing out every single object that I'm creating. So if I wanted to kind of make this faster for my testing purposes, I would just kind of remove those NS logs. It wouldn't be, it would run a lot faster. But then I still have 36% of my time being spent in this generate object based on integer. And that's a pretty significant time, 300 milliseconds, and that's for every object. It breaks it out by method. So then I can break this down even further, and I can see, well, all right, my image is really fastly set. My string is fast, my number is fast, but this date formatter, creating it and converting a string to a date is combined consuming 32% of my time. So I can go in and say, all right, is it really necessary for me to have this date formatter? Is there a better way I can do it? Or I can just create a static and a state formatter. Since I knew that 26.7% of my time was spent knitting this date formatter. So then I'm going to go ahead and kill this process. I'm going to rerun it really fast. Good point. So I run this big computation again. And I can see I finally get down to generate and display objects. Generate, and now I'm only date from string, which is kind of a necessary evil, is only consuming 6.1%, and my method has been reduced to 55 milliseconds as opposed to 300. So this is also really useful because you can take a performance analysis of your application and you can actually save it. Instruments, let's just say this one, and then you could take this, I saved that. So you can take this instruments trace and you could send it to someone, or you could save it as documentation for your boss that your application is efficient or whatever, or you could send it to someone else. The same works for leaks. You can save those traces, and if I just reopen it back up, and it'll just give me the same exact view that I was looking at before. So any questions on Time Profiler? Nope. Sorry to keep you guys a couple minutes late. We had some connector issues earlier, so we started a little late. But if you have any questions about assignment 5 or anything we've talked about today, Steve and I will be around for a few minutes. Feel free to come talk to us. Also, feel free to email us at the course list, and we'll be sure to answer your questions. Thanks.
For more, please visit us at stanford.edu.